Wow, 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 wow. Airplanes, baby, we gonna learn some applied meteorology today. I ain't got the shirt on because my shirt I'm wearing today is in the dryer. Now, we about to learn some applied meteorology. The first step about life is you got to hit life like a hungry dog on the back of a meat truck. All right, let's learn some meteorology. All right, so the wind at 5,000 feet, AGL is southwesterly, while the surface wind is southerly. The difference in direction is primarily due to friction between the wind and the surface. So when friction hits the wind and the surface, that's why you have two different wind directions. Okay, convective circulation patterns associated with sea breezes are caused by cool, dense air moving inland from the water. So you got cool, dense air moving inland over the water. That is what causes convective circulation. Okay, how will frost on the wings affect takeoff performance? So, frost will disrupt the smooth airflow over the wing, adversely affecting its lifting capability. So, just think about the frost accumulating on the wing. It doesn't make it smooth anymore. Okay, so every physical process of weather is accompanied by or the result of heat exchange. So, heat exchange is what causes all, like the sun hitting the earth and causing it to heat up. That's what causes the weather to act all cray-cray. All right, a temperature inversion would most likely result in which weather condition? An increase in temperature as altitude is increased. So inversion, think opposite. So normally as you get higher, that the temperature gets cooler, but when you have an inversion, when you get higher, it gets warmer. So think about that as an inversion. The most frequent type of ground or surface-based temperature inversion is that which is produced by terrestrial radiation on a clear, relatively still night. So when you got clear cloud coverage, all the heat can escape. All right, it's colder at the surface, and then as you get higher, it gets warmer because all that heat is radiating off the surface from rocks and stuff like that. What is meant by the term dew point? Dew point is the temperature to which air must be cooled and become saturated. So dew point is when the air molecules like moisture molecules in the air condense and become water molecules. So it's the temperature to which air must be cooled to become saturated. Okay, the amount of water vapor which air can hold depends on air temperature. So the amount of water vapor which air can hold depends on the air temperature. So the hotter the temperature, the more it can hold. The lower the temperature, the less it can hold. That's what turns to water. Okay, clouds, fog, and dew will always form when water vapor condenses. So when water, that's the easy one right there. Just when water vapor condenses, that's when it forms cloud, fog, and dew. Okay, what is the process by which moisture is added to unsaturated air? Evaporation and sublimation. So whenever you have evaporation, that's when you got water turning into water vapor, and sublimation is going from like ice to water vapor. So that's just water becoming vapor. Okay. The presence of ice pellets at surface is evidence that there is a temperature inversion with a freezing rain at a higher altitude. So think about that. You got water droplets that it's warmer. It's caused by temperature inversion because it's warmer at the higher level. As it comes down, the water freezes to become ice pellets. So just think about that. If there's ice pellets, that means it was once rain, then it froze into ice pellets, now it's hitting the ground. Okay, what would decrease the stability in air mass? Warming from below. So warming from below would decrease the stability of an air mass. So warming up below is what's going to cause the precipitation and the rain and all that. So just think about that. Warming from below, that's what's going to cause stability in an air mass. Okay, what is a characteristic of stable air? Stratiform clouds. All right, so you think about the high clouds up on top. Those are stratiform clouds. It's very stable air, good flying conditions. Okay, if unstable air mass is formed upward, what type of clouds can be expected? Clouds with considerable vertical development and associated turbulence. So if an unstable air mass is forced upward, what types of clouds? So if it's the unstable air mass is going like this, that's why you see those big towering clouds. It's going to be push them upwards. They're going to be able to build big clouds like that. What feature is associated with a temperature inversion? A stable layer of air. So a feature is associated with temperature inversion is a stable layer of air. What is the characteristic of moist, unstable air mass? Cumuliform clouds and showery precipitation. So moist. Think about thunderstorms. They're moist and stable cumuliform clouds and shower precipitation. What is a characteristic of unstable air? Turbulence and good surface visibility. So you got unstable air. You got air that's moving around. You can see for a long ways, but it's turbulent. It's bumpy. Okay, a stable air mass is likely to have which characteristic? Smooth air. So that's good flying conditions right there. The suffix nimbus is the clouds. That means a rain cloud. So think about NIMBY. He's all nimble and stuff. He moves around and rains on stuff. I don't know if that makes any sense, but it does to me. All right, so clouds are divided into 4 families according to their height range. So how tall the cloud is, towering, cumulus, stuff like that. Just the stratus, the little thin ones. So it's all about the height range. How high can you go? Okay, the boundary between 2 different air masses is referred to as a front. So 2 different air masses moving through, that's a front. Okay, when a cold front overtakes a warm front and a occluded front is formed, that's like when the cyclones form. So you got the cold, here comes the cold air front and it overtakes a warm one, and they form like cyclones. All right. Clouds can form indications about what 3 things concerning the air around them. Upward motion, stability, and moisture. So clouds can give indications about 3 things concerning the air around them. Upward motion, stability, and moisture. What cloud type belonging to the low cloud family and only occurring at surface to 6,500 feet is a stratus? Not circostratus, not altostratus, but stratus, up to 6,500 feet. Falling rain that never reaches the ground due to rapid evaporation is called virga. So it never reaches the ground. So it's so hot before it reaches the ground that it go ahead and evaporate. It's going to be very humid that day. Fronts are named according to the temperature of the advancing air relative to the temperature of the air that it is replacing. That is true. Fronts are named according to the temperature of the advancing air relative to the temperature, cold front and warm front. In what situation is advection fog most likely to form? An air mass moving inland from the coast in winter. So, advection fog, an air mass moving inland from the coast in winter. That's like warm air mass, and it just hits the cooler air, and it creates fog. So like really hot and humid air creates the cold air, and it just creates fog because it condenses. Low-level turbulence can occur, and icing can become a hazard in which type of fog? Rain-induced fog. So low-level turbulence is really bouncy, and icing become a hazard in which type of fog? Rain-induced fog. Okay, so it's going to be colder as you get up. It's going to be raining. So if the temperature dew point spread is small and decreasing, and the temperature is 62 degrees Fahrenheit, what type of weather is most likely to develop? Fog or low cloud. So if the temperature dew point is spread small and decreasing, so the dew point is the numbers are getting small and it's decreasing, the temperature is around 62 degrees, what is likely to develop? So that dew point is when it can condense to the fog. So as it gets lower, fog or low clouds can develop. What situation is most conducive to the formation of radiation fog? Warm, moisture, overload, flatland areas on calm nights. So what situation is most conductive to form radiation fog? So radiation like the sun hitting the earth. So warm, moisture, overload, moisture over flatlands on calm, clear nights. So whenever that warm air is going over on like think of the summertime, when you got open skies and that warm air moves over, it's the ground temperature is going to get lower and it's going to decrease, or it's going to turn to fog and dew radiation.